Thanks, Fiona. And hi, everyone. Thanks for coming along today. I'll get straight into it. So humans have been mining resources for tools and for trade forever. And, we can't really avoid the reality that to keep our society moving forward, we really need to, especially as we're moving towards renewable technologies, we're going to have to keep mining. But this creates a lot of waste, including a massive buildup of tailings waste. And it's well known that tailings have the potential to harm the surrounding environment, and there are expectations around tailings management these days to ensure that storage facilities are safe, stable, non-polluting, sustainable and socially acceptable. And one way to address these expectations is by using plants, but plants don't grow easily in tailings, and because of their multiple adverse characteristics, we can't really treat tailings as soil, and natural soil development can take tens of thousands of years, and we can't afford to wait this long. So the use of organic amendments has become a popular method to improve the physical, the chemical, and the biological properties of tailings in order to support soil development. However, there's currently no consensus on when amended tailings can be considered a self-sustainable soil. So that's where I come in. My research intends to understand what is influencing the rate of soil development in tailings waste and determine what those keystone drivers and thresholds are for the development of a sustainable soil from tailings waste. And I want to know, can we effectively accelerate those soil formation and those soil development processes? So I'm using a two-part investigation, linking and comparing studies of multiple aged and rehabilitated field sites with controlled pot trials. And in these pot trials, I'm incorporating various types and application rates of organic amendments in order to investigate what kind of effect these amendments have on the initiation of soil development processes, and as also learning a bit about their long-term effectiveness. So to learn about this, I'll be using soil state indicators such as texture, bulk density, plant health, and rooting depth, and standard laboratory tests for things like pH and salinity, nutrient availability, and the essential soil organic carbon. Alongside these, I'll also be using some more technical methods, such as X-ray diffraction to look for the evolving mineralogy that's happening within the tailings, and microcomputed tomography, which uses X-ray technology to produce a fine-scale, high-resolution 3D image of the developing soil structure within the tailings material. It'll sort of look at the aggregation and the porosity within those tailings. And the results from these studies will potentially provide a balanced and holistic look at the developing system and enable a deeper understanding of the processes involved in the evolution of the tailings towards soil. And this is critical information regarding effective, sustainable, and ultimately economic solutions, not just for the mining industry, but for environmental management of any landscape that's been severely impacted by multiple degradation factors.